Okay, I think we should start because we have a schedule to follow. So, good morning, everyone.
Good morning.
Just a quick check. Can everyone hear me clear and loud? Yeah, that's a good thumbs up. Thanks, everyone. Thank you, everyone, for being here at Abbotsford and at Northmead, and for those who are joining us online. And I would like to welcome you all to another exciting series of this technical talk. And I can see some really amazing people joining us online, and obviously people sitting in TAD Lab and here at Abbotsford. Thanks everyone for joining us. For those who don't know me, I'm the lead engineer at SolveTAD, based in Melbourne office, and I will be your host for today's event. Just for some housekeeping, please make sure to keep your microphone on mute when you're not speaking. You will be given, will give you a chance after every speaker's talk for any Q&As you have. I have Tom sitting next to me who's gonna look for any questions on chat, and Evan is gonna entertain us for any questions at the CAD lab, and feel free to the people who are sitting next to me to ask questions because everyone can hear us. Okay. I just want to do a country acknowledgement. We recognize the traditional custodians of the lands and the waterways where we live, work, and play. We acknowledge country which always was and will be Aboriginal land, and show our respect for elder, past, present, and emerging. I would like to request our CEO, Scott Miller, for the opening remarks for today's event.
Yep, thanks very much, Hassan, and congratulations, Evan and team, for bringing us all here today to have this opportunity to do a tech talk. As you'll know now, I'm Scott. I've been in the organisation about 3 months, and I'm delighted to have this role, working with you to change the lives of people with a disability by providing personalised technology, equipment and services, and recognise your role as integral in the link in this chain. Tech Talks are a great opportunity to share the advancements in technologies and the reciprocal arrangement between your expertise and our speakers' expertise. It's also an opportunity to connect with universities and hear the latest in advancements in technology using a co-design approach. And today we thank you, Pang, for your time and wisdom to share with us. It's also an opportunity for our volunteer workforce to hear about recent projects from fellow peers. It's truly one of the inspiring parts of this job to hear just the originality and the expertise that goes into some works. As a Kiwi, we need to kind of take this message across there, because we take pride in New Zealand of calling ourselves, the home of number 8 wire ingenuity. But I think we need a similar sort of a term for the way Australians can come up with some really incredible solutions. So thank you, Marco, Kirk, and Whitney, for your time this morning for doing that. Look, I understand there's been more than 200 people that have joined our Tech Talks. 20% are connecting from regional areas. And as you know, we're a merged organisation, so it's delightful to know that we have people from across New South Wales and Victoria. So thank you, everybody. Enjoy the day, enjoy your session. And if you're in person, we look forward to sharing a cup of tea and a bit of a bite with you. And next time, hopefully, we'll see you in person at some stage, hopefully at the Christmas function. Back to you. Thanks, Hassan.
Thank you, Scott. Thank you very much. Before any further delay, I would like to hand over to our guest speaker, Dr. Pang, for his exciting talk. So he has been working closely with the Australian Stroke Alliance and will be sharing his experience on bringing the CT scanners to the skies in designing a CT scanner for an air mobile stroke unit. Dr. Pang has been working at RMIT University for over 10 years and specializes in teaching, learning and research that integrates 3D technology and software in modeling, and to deliver user-specific product requirements in addressing the increasing demand of the customized solutions. Dr. Pang.
Thank you, Hassan, and thank you, Scott, for inviting me to this talk. And I'll share my slides. Hassan, would you be able to share the slides?
Do you want to share it, or do you want us to share the slides?
Yeah, I can't share it for whatever reason.
That's not an issue. Maraika, would you help sharing the slides for Pang?
Yeah, thank you. Thank you, everyone, for coming to this talk. And I'd like to present the work that we've done together on Light CT scanner. And I would like to acknowledge my co-authors who are also working on the project, Professor Kat Fox, Kern, and Hayden. Next, please. And as you know, as Hassan mentioned, this project is pretty much sponsored, and the resource came from Australian Stroke Alliance, and the research is in collaboration with Royal Flying Doctor Service, Ambulance Victoria, and the Stroke Foundation. The resource was funded by the Australian Government Department of Health Medical Research Future Fund. Thank you. Next slide, please. And throughout this presentation, this is an overview of the presentations, how I'm going to go through with the Light CT scanner. I'll provide some background information about the stroke, the golden hour, and the concept on mobile stroke unit. Then I'll go through how can we take the CT scanner to the skies. Next slide, please. Strokes can be classified into two main categories. The first one is ischemic strokes. These are strokes caused by blockage of an artery in the brain. The second one is a hemorrhagic strokes. These are strokes caused by bleeding in the brain. And we know that strokes may lead to severe neurological impairment or brain damage if not treated within the golden hour, between 3 to 4 hours. Next slide, please. We refer to mainly the acute ischemic stroke, which accounts for about approximately 87% of all strokes. The treatment using tissue plasmogenic aviator, in short form TPA, within the golden hour, which is 3 to 4 hours of strokes symptom onset, could reduce the risk and disabilities. However, the administrations of TPA require prior brain scan with a CT scanner for the medical team to determine the suitability of such medication. And why the golden hour matters. Long-term brain injury can be avoided if the patient can be attended to within the golden hour period, between 3 to 4 hours. If we prolong the treatment, then the brain damage is irreversible. Next slide, please. At the moment, the stroke incidence being 20% higher in the rural and remote area. The treatment received and how fast the patient can receive it vastly depends on where they are based and how remote they being. So only at the moment, 3% of rural and remote stroke patients are getting the treatment in the stroke unit. And some have to travel more than 200 kilometers to have access to the stroke care. Next slide, please. So in any acute ischemic stroke cases, the protocol of treatment is first to complete a brain imaging and other tests. And patients will need to be transported to the nearest emergency department, either via the ambulance or helicopter. Any delay will hinder the treatment within the golden hour. Next slide, please. In order to approach the time-sensitive stroke treatment procedure, the concept of mobile stroke unit, in short form, we refer to as MSU, was first introduced in 2003 with the idea to bring the hospital to the patient. And a customized MSU will consist of multiple integrated systems, such as a modified mobile stroke CT scanner for obviously the brain imaging, a telemedicine system, which can transfer the image and patient's data to the closest emergency department, a point of care lab to determine the suitability of treatment, and a stretchers that's to position the patient into the CT scanner so that we can collect the image. Next slide, please. As I mentioned earlier, patients in rural and remote areas of Australia has limited access to stroke unit. Hence, the concept of AMSU is proposed to deliver stroke treatments to rural and remote patients. However, there are some technical challenges and limitations. For example, we need to come up with the optimal weight and balance if we were to fix a CT scanner into an aircraft, as they will affect the flight performance. And the material used interiorly has to comply with the standard guideline with flammability requirements. The CT scanner also must be resilient to any vibrations or any sudden change of pressure or temperature during the flight. These are the limitations or challenges that we need to address when we consider to putting the CT scanner into any aircraft. Next slide, please. So for the choice of aircraft, we have considered between a fixed wing, which can cover a larger distance, but which require a longer runway, or a rotor wing, which has a smaller coverage distance and also lower speeds. Some other factors that we need to consider are obviously the distance cover, the cabin space that we have, any weight restrictions on the aircraft, and any landing options. Next slide, please. Before we move on to what scanner to be chosen, we have looked at there are a range of commercially available CT scanner, such as the Ceratome, the Omitome, Scan, which is presented in front of you. The weight and dimensions also varies from scanner to scanner. And you can look at the Omnitome. So the weight of it about 726 kilogram, and we need to reduce it before we can even place it in the aircraft. Next slide, please. Before modified for retrofitting, so we're going to retrofit an existing mobile CT scanner into the selected aircraft. So we need to consider the major component of a CT scanner, which we can remove, which we can modify, and which we can replace. For this project, we are selecting a Ceratome scanner, and which is presented in front of you. And we look at its major component. For instance, the X-ray tube and the detector, we are not touching it. The hidden components such as battery and computer, those are the components that we could replace. Next slide, please. So in order to bring CT scanner to the sky or integrated into a selected aircraft, as I mentioned before, we need to do some modification to the existing CT scanner because they are built for hospital. They are bulky, they are heavy, they're big in dimension. So we have to consider two design and development approaches. The first one is the traditional linear waterfall approach, or the next one is the model-based system engineering diamond approach. I'll go into details, these two concepts, and I'll explain which concept we'll be using. Thank you. Traditionally, the design and development of any medical devices have followed the linear waterfall approach. It is a basic logical sequential design process. It starts with understand the user requirement, any constraint or any regulatory requirement. Then we follow the engineering design process. For this approach, each phase must be reviewed, verified, and complete before the next phase can start. And this approach is not suitable for complex designs such as a CT scanner. Next slide, please. And hence, we propose a new approach that can integrate collaborative and concurrent product design with the use of model-based system engineering approach. And in short, I will use it, MBSE. Through the MBSE approach, we would develop a digital twin, which is a virtual replicas of an existing CT scanner and aircraft. And we will use the bidirectional connections of data between the digital twin and the physical assets. And we use computer simulations to computer modeling to design and to analyze the performance and suitability. With this MBSE approach, we can virtually test the performance of the product before we build a prototype to test it, and it will reduce the design and development time. Next slide, please. Here, this is the process that we currently use to complement the MBSE approach that we propose. So this is the framework that we use, which highlights the details of the process. We start with understanding the project specification, which scanner we selected, and in each phase, we cover the conceptual design, and we validate it using the physical asset. So for instance, in the project specification phase, in step 1, we will understand the user requirement. We interview the mobile stroke unit staff to understand what is needed, what would help them to do their job easily in the confined space. And we look at the technical specifications, and also we need to understand the regulatory requirement. For instance, the Therapeutic Good Administration Act that we need to confirm too. Once we understand this sort of requirement, we start our conceptual design. We reverse engineering the existing CT scanner and also the aircraft. Then we start the detailed design process. And finally, we'll build a prototype and do the testing. And this process will pretty much validates what we found in the virtual analysis compared with the physical testing. Next slide, please. For this project, the ultimate goal is to fit the Ceratome into an Augusta Westland 189 aircraft, where at the moment the CT scanner, the size, the dimension is given on the left, and the weight, the total weight of the current CT scanner is about 430 kilograms. And we need to reduce the weight and its current dimension to retrofit into the Augusta Westland 189 helicopter. Next slide, please. And here is the process that I just mentioned before, the framework that we use. So we start with the conceptual design. We look at the current existing CT scanner, and on the top left corner there's an indication where the structure that we can modify and optimize to reduce the weight. The red color components are the component that we can remove, and the gray area is the component that we can reposition, and some component we have to keep it at ease. Next slide, please. Based on our analysis, we have already worked out the support structure. We can optimize it to reduce the weight. So we considering what using the virtual design approach, we look at how we can further reduce the weights. And also we look at the support structure, how we could reduce the weights further. Next slide, please. And the base plates are currently designed to support the CT scanner to be fixed within the hospital setting. So we need to look at how we can modify the base plates so that we can retrofit the CT scanner onto an aircraft. Next slide, please. And we look at the whole assembly. These are the virtual model of the existing CT scanner. So you can see at the bottom diagram there are some hidden features that we couldn't see in the diagram, but we can, with the virtual model, we can actually look into it detail. And these are the components that we cannot touch, and we need to keep it as a constraint. And for instance, the motor, the gearbox, we can modify it to retrofit it into an aircraft. Next slide, please. Because the CT scanner has to be retrofit into the aircraft, so during the takeoff and landing, this CT scanner has to be in place and locked in place. So we need to look at how we can modify and put in a locking pin to secure the CT scanner during the takeoff and landing. So this is a part that we need to properly consider. Otherwise, during it might cause any movement and it might damage the CT scanner. Next slide, please. Here, this is the concept that we put the CT scanner into the selected aircraft, and we measure the dimension and to look at what space we have, how much space we have, and what's the dimension that we need to reduce so that we can fit this existing CT scanner into the space that we have. And we also need to allow some space for the medical team and the nurses and the radiographer to work around the patient when they do this scanning. So we have to understand what sort of space that we have and how much we need to reduce the CT scanner in terms of the dimension to fit into the aircraft. Next slide, please. So throughout the exercise or the project, there are some challenges that we face. For instance, we need to find an optimum balance between minimizing the weight and also the dimension without compromising the structural integrity of the current CT scanner. And we understand by fitting the CT scanner into the aircraft, we need to consider the impact of vibration. Because if there's a huge vibration, it's going to compromise the quality of the image that we're going to get. We also need to meet the regulatory requirement because we are modifying the current existing CT scanner. So we need to make sure that we still conform to the regulatory requirement. Also, we need to be mindful that because we are using existing CT scanner, so that we don't infringe any intellectual property. And obviously, the overall safety of the aircraft and also the CT scanner has to be factored in. Next slide, please. So throughout this project, the research is mainly focused on the feasibility to retrofit an existing aircraft, how we be able to reduce the weight and reduce the dimension to fit into an aircraft. At the moment, we already completed the design phase. The next investigation is to pretty much build a prototype to test it in the lab. And that's the next phase that we're going to look at. Thank you.
Thank you, Dr. Pang. Was really an interesting topic, and I would like to open the floor for any questions we have. Anyone has any questions on Zoom, they can put it on chat. And anyone has questions in TAD Lab, Evan is happy to entertain them.
I'm happy to kickstart it at Northmead. Marco's got his hand up, and then I've got a question as well that I may get asked.
Yes, Marco here. Thank you very much for an interesting topic there. I didn't hear in any of the discussion you had working with the manufacturer at all. Did you contact them to see, whether the changes you were making were going to affect things, and did you get their CAD model? How did you interact with that manufacturer?
Thank you very much for your questions. Yes, that's a very good question. We do work with the manufacturers of the current CT scanner, which is Siemens, and we also work closely with the technician. Unfortunately, they can't share with us their CAD model. So what we did, we reverse engineered the CT scanner. So we did photography and we did some scanning, and The simple part, we just pretty much do the measurements and reverse engineer built-in CAD. The complex component, we pretty much use photography, and then we use the CAD software to stitch them all out to reverse engineer the CAD model. So we do work closely with the manufacturer, but there's a lot of information that they couldn't share with us. So we have to, some of the component we pretty much have to guess.
Okay, thank you.
Question from myself, Pang, over Northmead in Sydney. Thank you. You definitely meet the criteria to be a technical unique solution volunteer. So if you ever want to volunteer with us, I think from my perspective, what made me think that though is a very commonly unique solutions. We don't always build a product from scratch. We will look for something that's commercially available that the client may have already identified, but it doesn't quite suit their needs, and we would actually modify that product. So we've never had to modify a CT scanner, but we definitely have to modify and adapt an existing commercial product. My question for you, I found that I really liked the design principles, the co-design principles behind it all, and how it actually evolved. It requires working with multiple stakeholders, whether that's the manufacturer, whether that's different departments, faculties in the university, whether that's users, whether that's health professionals, with a fantastic outcome of helping people in regional and rural areas, which I'm always an advocate for. What are some tips you could give us, especially our volunteers and all of us, when you're actually juggling multiple stakeholders?
That's a very good question. Thank you. At the moment, we are using a unified platform, which is the software that we currently have within RMIT. So we invite all the stakeholders to be on the platform, so that this unified platform is very much the one source of truth, so they can share all the files rather than asking for some document. They email us and then we have to upload. We pretty much invite all the stakeholders to be on this unified platform, and so that they are given the user ID and password is secure, and they can log in and whenever they need to upload any document, they can upload, and they can email us after they uploaded the document. Then all the user be notified that the information is there, so that we don't lose track of any information. We make sure that the traceability of information is there. Obviously, this is a large project, as you said, mentioned before. We have 2 parallel projects running at the same time. Our team pretty much looking at the existing product, trying to modify to retrofit into the aircraft. There's another team that start from scratch. So they look at how to build a new, small, lightweight CT scanner for a new aircraft. But somehow, because it's a new product, a new concept to have a small CT scanner, because the CT scanner is not commercially available yet, it has to go through all the regulatory approval process. So they have not moved as fast as what we are doing currently. So our team actually already moved into the prototype testing phase, whereas the other group come up with the concept, a new concept. They are still in the development phase.
Thanks, Pang. And the next space sounds very exciting.
Thank you.
We've got a question from Fred.
Yes, Fred Thompson. Do you have funding for the project? Is it a goal, or is it just simply a design exercise at this stage? Is it fully funded?
Yes, this project is fully funded by Australian Stroke Alliance and also by the Australian Government Department of Health Medical Research Future Fund. So we have received, no, the Stroke Alliance project is about $42 million. Our team get a portion of it to develop this CT scanner with the hospital, with Royal Melbourne Hospital and Siemens, who are the manufacturer of the Serotom scanner.
Okay, thank you.
Thank you, Fred. We've got a question from Graham on chat box. The question is, how are you going to power the device at the remote location?
Okay. At the moment, that's a very good question, because from the regulatory requirement from TGA, all the CT scanner has to be powered, and also they need to have a backup battery unit. So at the moment, we are working with the aircraft team. When the medical team or the stroke treatment team perform the scan, the helicopter has to be parked. So it's landed, they are not moving, but the power has to be on. So it's landed, but the power is still continuous. So what we're doing, we work with the aircraft team. We're going to look at how we can integrate their power, the electrical device to power the CT scanner. If for whatever reason the power cut off, we still have, because based on the regulatory requirement, we still need to have a backup battery. So the backup battery will kick in if the power cut off. So we are not working silo just to design. We are also working with the aircraft team to see how we can integrate to power the CT scanner.
Thanks, Pang. We've got a question from David here at Abbotsford.
Obviously, the real bogey in all of this is weight. Now, the obvious thing is the lead screens. Is there nothing in this modern day and age that can take the place of lead as a screen? Also, the casing, could that not be 3D printed out of carbon composites?
That's a very good question. Thank you for the question. Yes, at the moment for our prototype, because we optimize the structure, so I didn't have it in the slides pack. The structure that we came out with is quite organic in terms of the shape. So we actually going to 3D print the structure, and we have considered whether we're going to use titanium, or now at the moment our team have decided to move into carbon fiber composite because it's lighter weight and also structurally is stronger. That's what our team have presented to the Australian Stroke Alliance group, and that's what they agree with. So we're going to go ahead by developing a mold so that we can lay the fabrics to build the structure. So that's the next phase that we're going to do. The structure is going to be built using composite material.
Thank you.
Thanks, David. Just want to wrap up with the last question, and I'm sorry if anyone has any questions later on. Feel free to contact me, and I'm happy to forward that to Pang. The last question on the chat is, how did you decide on the type of aircraft? What was the selection criteria for that specific aircraft that you selected? It's a question from Ross.
Thanks, Ross, for the question. That's a very good question. At the moment, we have 5 different aircrafts that we are considering. So, as I said, this project, we have 2 parallel projects running, and we are working with both teams. So the aircraft team, they have selected 5 different aircrafts, and 2 different category: the rotary aircraft and the fixed wing aircraft. So depending on the distance and the space that we have. So at the moment, we are reverse engineering 5 different aircraft of 2 different types, and we try to retrofit the CT scanner. Obviously, depending on the space, the cabin space that I have, we need to retrofit and how much we need to reduce that. For this current project, we already selected 1 aircraft because that is the aircraft that the Australian Stroke Alliance have selected. So we were working on the Augusta 189 aircraft. But to answer your question, we do have 5 other aircraft that we consider, and we are working with the aircraft team to see how we can retrofit the concept that we have into their space.
Thanks, Pang. I just want to wrap up by saying thank you to Dr. Pang and his team. I think it's an exciting work and research development happening, and we look forward to having these in future at some stage. Just a round of applause for Pang and all the people. I would like to move on to our next session, and Pang, you're most welcome to stay for the volunteer presentations. I know you're pretty busy with the end of semester and the RMIT exhibition that you organized yesterday. Thanks for that. So feel free to stay, or if you would like to leave, it's up to you. Just moving on to the next.
Thank you.
No worries. The volunteer presentations. We have our first presenter, Marco from New South Wales. And he's gonna present a recent project he's working on called Enclosed Bed.
Thanks, Hassan. We're just getting ourselves sorted. You should all be seeing the screen now. I can't see it, but I'm guessing no, you can't see it either.
I think that's the last slide, so you have to go up.
That's weird. Hold on a sec. Can you stop sharing? To the full screen. When you display, does it display up a different monitor?
It's going to triangle slide. That's one. Let's go.
Okay.
Another second.
Yes, here we go. All right. So yes, this project is for a client called Maya, who's 4 or 5. She's diagnosed with Rett syndrome. Now, Rett syndrome is extremely rare genetic development disorder. It affects mainly girls, about 1 in 10,000. The arc of the syndrome is that they, up to about 18 months, they develop more or less normally, but then they fall behind and then they deteriorate. So significantly affects the development of the brain, and eventually they lose motor skills and speech, and it's permanent, lifelong, and currently no cure. And it also shortens their life. However, while they're children, it causes significant sleep disturbances, and that's why we need a special bed for her. The way it manifests, and I've seen a video of Mia, basically she's in a cot at the moment, or she was in a cot, a standard cot, an IKEA cot, basically. She stands up and roams around the bed, around the edge of the bed, chewing the top of the cot, and then tries to climb out. So we've got to stop that. And make sure that she's safe within the cocoon. And the reason I'm saying that is because when you see what the design is, it's a bit confronting. But that's what the OTs say we need, and that's basically the way. Click on it. Yeah. So the project brief is to create an enclosed bed, and the 2 main things are that it's got to be low enough onto the ground so she can climb up and get in herself during the day if she wants to have a sleep. And it's got to be safer, as I said, safer to move around inside when the doors are closed. There were other considerations that before they came to TAD. Commercial model, that's the picture of the commercial model there. What happened? Yeah, that's a picture of the commercial model there. You can see that it is like a bed with a cage around it, essentially. A cot for adults, that would be single bed size. They're very, very expensive at $18,000. For an electrically powered version, I think it's probably like 15 for something that isn't electrically powered, more like what we've built. They'd seen that price, they went to see whether a third party could make them, and a carpenter quoted them about 10 grand. At that point, they came to TAD for I don't know how they contacted us, but they came to TAD. We did a design, which I'll cover in a minute. Costing to us in materials was about $3,000. A couple of other factors for this particular family was they live in Wollongong, so I guess that's remote from Sydney, and it's a remote area. We'd consider it a remote area from Sydney. So we needed to be able to ship this from Sydney once it's made to them. So it needed to be a flat pack, essentially, when it was shipped. The parents are separated. This is important because the NDIS funds the mother's location, but won't fund the father's. So the father has to self-fund it, which is why the cost becomes important. I think in the end, we've got foundation money from TAD to pay for it. So he's essentially not funding it, I guess. The father lives in a rental property, so he may move around. So again, once it's built, it might need to be dismantled to be able to ship somewhere else. So there's a few things there to consider just from a lifestyle point of view. Design parameters that emerged when we started to talk to him about it was he wanted to use an existing mattress, which was a single size, so it's 920 by 1880, and it was 250 millimeters thick. He wanted so the commercial model extends to about 1.8 meters above the mattress. He thought 1450 would be suitable for Mia, allowing for some growth. He wanted the mattress to fit really snugly within the space, so a minimal 5 millimeter allowance around it, just so you can get the mattress in. And the mattress, or the bottom of the bed, had to be 50 millimeters above the ground to get some airflow in there. And then obviously once you start adding a few things, probably more like 400 by the time you get to the top of the mattress, and then you've got 1450 above that. So overall, when you look at the design, the height of it is almost the same as the length of the bed. As I said, the locations are rented home with standard door opening, so nothing has to be bigger than what you can fit through the door and carry in. We needed to ship it from here to Wollongong. Obviously, minimising cost was a prime factor. Because they'd done all the research and there was commercial designs, that's really a good point to start from a point of view of what we want to design. And importantly, the father said he was handy, I guess, quote unquote, and he would be able to put it together once it arrived down there. So they're the kind of parameters that we're working with. So it took about 2 elapsed weeks, maybe 3, but about 1 full week of design. That's the design in Fusion 360 that we came up with. Me, Marika, the father, the OTs reviewing it, and so on. So we considered a few things before this. And obviously the dowels would be the first option, right? You'd think about building something with dowels. However, when you look at inch dowels and the number that we had to put in, it became horrendously expensive to actually put that together. So we opted for plywood panels with a frame around them, and that was the basis of the design that you see there. So there's a bed base around which you bolt panels, and you can see the bolt holes down the bottom there. And the panels basically sit and provide the legs for the bed all round. And then the corner pieces that you see there made out of plywood basically tie the corners together, which then stiffens the whole structure. And because it's modular the way it's been designed, you can flat pack it and ship it down, right? So plywood panels are used here in Sydney quite often because plywood in general, because we've got the CNC cutter. You can go straight from this design down to the machine. And the surrounds, which are white there and actually painted white in the final version, 70 by 35 pine, which is non-structural. You can buy a 2.4 meter length for $5 at Bunnings. So there's a lot there. So it all ended up $3,000, but the materials themselves are actually reasonably cheap. So as I said, it was modeled in Fusion 360. This made it really easy to interact with the client. So I'd do a design, it would go to the client, they'd look at it, they'd suggest improvements, so things like bar spacing, the closure mechanisms. We kind of discussed whether Mia would be able to put a hand through the bar to lift those bars that are across the door, for example. Father thinks not. So we opted for the simplest version that we could do, which is basically a hook with a bar. And the top bar, by the way, is installed higher than she can reach. So realistically, she won't be able to open that one, even if she can get to the bottom one. And the OT reviewed this. There is a pinch point where the hinge is on the door. They felt it was fine because the door would only be closed with adult supervision. And so a whole bunch of things were considered. We then did the CNC parts directly from the model. I did my own workshop drawings directly from the model. And then we did an accurate cut list, which I came in and cut here at TAD with the cut saw they've got here. So literally while the plywood panels were being done by machine, I was cutting the rest of the timber to the dimensions required. So that helped to actually speed it up. So construction was about 2 weeks. Here you see it all laid out in my garage. Basically the panels, about 2 weeks construction, 1.5 was really mostly preparing pieces, painting them, and then the last 3 days was really just assembling the panels onto the frames and putting it together. The frames were actually put together with internal screws on the back that then get covered over by the plywood panels. So there was you don't see it too much, and the plywood panels are attached with screws that are inset. What's it doing?
I think it's on a timer.
Oh, okay. I'm not talking fast
You're
enough.
not quick enough.
Bloody hell. So you can see the panels there, how it's constructed, and there's a close-up shot on the inside when the door was being fitted. The key thing is that the inside has to be flush so that there's no protrusions and there's nothing for the child to chew. Once she's in there, she's safe and moving around inside. This was the final check and a flat pack. So final check, Barry came over to have a look at it, make sure it was all happy. You can see I've temporarily put in the corner pieces just to check for stiffness and so on. And then it was flat packed. All the screws and nuts are in the box. And you can see the flat pack is as it is, and it's pretty much the size of the base, just stacked up. And the stuff at the back is just at the back because it was easier to stack it up that way. The only panels that weren't single panels was the door and the hinge, which had to go together, but that again was just a double panel. Okay. I wrote some instructions for him to put it together. So what tools he needed, the sequence to put it together in. As you saw in the beginning, all the panels were numbered, and you can kind of see it at the top of the semi-built bed at his house. You can see the instructions on the floor. You can see the tools and the bags with the bolts and stuff on the ground there. He seemed to put it together with no problems up to that point. Then he needed help to actually, kind of hold it together while he put the corners in. So that's when we got the photo, and he was continuing. So now being rushed, that's it. I think that's the end of the presentation. So if you want to start on time and finish on time, you're right. That's it from me. I mean, it's obviously a big project. There's lots of stuff in there. It is confronting when you look at it, but that's what was required in the end. And everyone really, well, he's happy with it. The father's very happy with it at this stage. He won't put the child in there until an OT goes over it. So the OT will be able to okay how it all works. But they've done it off the model. I don't expect they'll have too much of a problem once it's there. So that's it.
Great. Thank you, Marco. Anyone's got any questions?
Marco,
Question at Northmead from Colin Hunter.
hello everybody. Marco, you didn't find there was too much flexibility in the half-inch ply over such a long distance with the cutout?
Not too much. There is definitely. It probably moves around. But the bars are 55 together. So if you can get if you move one to the other, like that, you can get a gap through there. But it is a child in there, right? So they're not got the strength probably to do that. My main concern was that they'd be able to slip their hand in and just simply pop one of the bars off and escape, if you like. So that's why we put the top bar at the very higher than she can reach. Yeah.
And who had the job of sanding it all down?
Luckily, we used a new bit for the slots, so it was really only around the corners where it curves, where you get all the cross grain, that was a bit tough, but all the rest was, yeah. That's why it took so long. I mean, the painting and by far the longest thing there was the painting.
Yeah, there's a question here from the chat that Hassan will share.
Yeah, so we've got a question from Denise. Could you do this again? I know there are another syndrome that would benefit.
We definitely have the plans to do it again, and someone else could do it again, no problem. Because it's a model and it's built and we have drawings, it's really straightforward to replicate.
I think that's really good. Any other questions?
I've got a question. Hello. This is not necessarily a technical question, but and I might have missed it at the start. But did you say Mum's Bed got funded through NDIS, like not the one that you did, but another commercial one?
Yes, correct. She got I think she got a commercial one. I don't know the details, but I'm assuming she got the commercial one, which is why they knew there was a commercial version.
Sure.
Thanks, Whitney and Marco. Really an interesting project, especially the way you have presented it, the process that you have followed. I really like the way you've provided the user manual. I think it looks like something from an IKEA. You buy something, you come and you feel excited to put it together. So really appreciate your time and effort and all of the work that your team at Northmead is doing on this project. Thank you once again. Just a clap for Marco for this.
Just a quick note, Hassan, if I may, just I guess credit as well to our main CNC operator, Mike Muir as well. So a volunteer of ours. So that's about 8 to 10 sheets of ply that you see cut on that project.
Yeah, thanks, Mike, for doing all the amazing stuff you do for us on the CNC. Just moving on to the next speaker, and I'm really sorry. I think we have so exciting topics today, so some really good questions. So we are running a bit late on the schedule, so that's fine. I'll move it on to our next speaker, Kirk from Barwon Branch, Victoria. He's gonna present another exciting story, a project which is 3D printing mouse for gaming.
Hi, Hassan. Can you hear me?
Yes.
And can you see my slides? Because I've got 2 screens. It's a bit confusing here. So you can, yep. All right, good. I'll kick off then. This one's titled Adaptions to Enable Participation in Gaming. So we've got a client, a male client in his mid-30s with spinal cord injuries. He's in a wheelchair. He's got some movement in his upper limbs, and he's got some wrist movement, wrist flexion, and he's got some elbow movement as well. But he's got no finger movement. His hands are permanently closed in a fist, so he's got no ability to use a mouse. And there was consideration of using a standard keyboard with typing splits, but that wasn't considered suitable for what he wanted to do, which was to try and do some gaming. So I was given the project in late 2021, and it started out as an RMIT, I think it was a 3rd year biomedical engineering student project, and there was a team of 4. And basically the brief from Hassan was finish the project. Now he might disagree with, there were more words than that, but that's how I interpreted it. So I had to finish the project. And the students had done some concepts, and that's a picture down the bottom of an earlier version of what they came up with. Now, I found it personally quite a challenging project, and I felt a bit sorry for the students. They never met the clients because they were based in Melbourne, obviously, and the client was based in Geelong, which is why I ended up with the project. And with all the COVID restrictions and lockdowns and things like that, they never actually met the client. They never sort of got a chance to see the issues personally, or you know, how his injuries affected him. So I think given the conditions they worked under, I think they did an excellent job. And what they did actually formed the basis of the final design. So when you start to see the final solutions, it looks quite different to what they came up with initially, but it's still based on their original concept. So it was handed over to me. There was a 3D printed shell, which you saw an early example of that on the previous slide. There were no electronics at this stage. There was talk of building electronics and software, but no, they never got that far. And to give the students their due, they finished the semester, wrote up their report, but they continued to work on the project with me. And they continued to do that through Christmas and until their lectures start at the beginning of 2022. But some of the challenges we faced with it is they had one software package that they were using at the RMIT, and I had another software package, and we exported their CAD drawings into mine, but we lost some of the features in it. So, and that was always a problem all along, that, you know, I had the CAD drawings, but I couldn't edit a couple of the features. But anyway, we persevered, and although I wasn't very familiar with the 3D software package at the start, I was very familiar with it at the end, I can tell you. So this is what we came up with. So there's a couple of photos there. A 3D printed solution using ABS, which is just, I call it Lego, the same sort of plastic that they make Lego out of. It consisted of 3 parts: a base, and there's a picture on the left-hand side there of the base, a middle section and a top section. So the top section, which is where the client rested his wrist, was flexible, and the middle section basically supported the top section and connected those 2 bits together. I developed a number of prototypes, 8 prototypes, and each of those had a number of variations. Unlike the previous project where they seemed to finish it fairly quickly, I took a long time. I spent about 350 hours on the project. The material costs were minimal, but I spent a lot of time traveling because I'm on one side of Geelong and he's on the other, and it was backwards and forwards. And I actually delivered 2 versions, a wired and a wireless version. Now, why we had a wired and a wireless is a long story. I'm not going to go into that now. So just a couple of the prototypes. And the reason I did so many prototypes is because it was an iterative process. We didn't have, like, you know, some of the projects you do, you got to build the stairs or something. You said, that's what you got to build. We didn't know what the final solution would look like. You know, we had to explore what would work with the client. And so there's some of the iterations of prototype 1 on the left-hand side. And down the bottom is roughly what was handed over to me with the students, as I recall. And then we work collectively on that. And you can see it changing as we go along. You can see in the middle picture there on the left-hand side, or that middle image, we added what we call shark fins. And then on the top one, we added a wider base, and you could see us sort of trying different things. Now, at the end of prototype 1, the students started uni again, and then I was by myself. Prototype 2, we actually took a very different approach. I took a mold of the client's hand in modeling clay and then used photogrammetry software to create a 3D model, and then change the 2 of the parts to print a 3D version. And you can see that on the right-hand image, and that actually pivots, and there are micro switches underneath, but we actually abandoned that. That didn't work that well. Here are some further prototypes, and you can see it changing in the left-hand image at the top. You can see we added a handle, and the right-hand image, we added what I call fins to those handles. And, you know, you can see us evolving as the design went along. I'm not going to show you all the prototypes, but that's basically the 2 finished versions. Prototype 7 became the wireless version on the left-hand side, and prototype 8 became the wired version on the right-hand side. And on the left-hand side, there are 3 micro switches one on the bottom left, one on the bottom right, and one on the side. And on the right-hand one, there were 2 micro switches, one at the bottom and one on the right-hand side. It had the extended base, and we had to rotate the printed circuit board or the electronics 20 degrees because at the time we didn't appreciate that normally, you know, your wrist is lined up with the lower section of your arms, but due to his injury, his wrist was slightly rotated and that was affecting the mouse. And like, it seems simple now, but at the time we're trying to work all that out. So there was all these issues that we had to deal with. So in conclusion, yeah, we delivered the project to him in August. He's got 2 versions there. I haven't heard any more back, but at the time he was saying, oh, you know, thank you. And he might get me next to build a joystick, which I was a bit shocked about. But anyway, I said, if you want a joystick, put it in through the usual channels and we'll see what happens. Yeah. Thank you.
A really good example of one of the RMIT projects going ahead and our client getting benefit from that. And thanks to Joanne for your support on this project to Kirk and other volunteers and students as well. Anyone has any questions?
What was the scanning process from the 3D clay into the 3D model?
I just searched the web for different packages. I ended up trying about 3 different packages, which were free packages, and I downloaded those to the mobile phone and scanned those and then created the image. And then it took me quite a while to then tidy up the images. I can't remember the name of the final package that I used. But that's basically how I did it. And then I did the 3D prints from that. It didn't work because you know, when you're using a mouse, you lift it up occasionally, and he doesn't have that. And you can saw in those early prototypes we had straps, and then in the later prototypes we have the handle to hold his wrist in. It didn't seem to work that well with that mold, although we could have put a strap across it. He didn't want to proceed with that, so we abandoned that.
Thank you. Great job.
Thanks, Kirk. Any other questions?
Just a comment from Evan in Northmead. Just so and everyone is aware, and Kirk, for when you do the joystick, we do now, thanks to some funding that we've received, that we do have a portable 3D scanner now.
Oh, okay.
So when you're offered that joystick job, let us know.
Okay, thanks.
Thanks, Evan. Any other questions? Okay, thank you very much, Kirk. I'm really glad this project is done and the client is pretty happy, especially with the lockdown, because I know it was a really challenging task to take the measurements and with these sort of hand shapes and different complex shapes. I think you've done a great job without a 3D scanner. So I'll move to our next presenter, Whitney. She's going to present on a project, scooter stabilizer, done by one of our volunteer, Richard. So I'm going to share my screen and
hi everyone. I will just start by saying I am aware that this is a technical talk, and I'm an OT here, so Hassan is going to take over the actual technical side of things. And yeah, as he said, I'm speaking on behalf of one of our wonderful volunteers, Dick O'Keefe, who actually came up with this design and project. And he had a really great relationship with this client in the end. So yeah, it's on behalf of him. So you see that? Yeah. So a bit of background on the client referral that we got in was a 94-year-old male who lived at home with his wife in a pretty amazing home in Brunswick, but very limited with space in the house, as you can imagine, like one of those sort of skinny 2-story small Brunswick homes. the main, I guess, part of what he wanted for the project was he has reduced balance just due to age and some decreased strength in his left leg as a result of a previous kneecap injury. So reduced like range of motion in terms of how much he could bend his left leg. But he does still walk around using a 4-wheel walker indoors. But when he goes outdoors or goes for longer distances out in the community, he has a lightweight folding scooter, which he had already purchased prior to me knowing him, and was using to get to library, shopping centre, exercise classes. So this is the scooter that he had or has, and the whole referral was that they would like to increase the sideways stability of the scooter. So this is quite a common thing that I see with clients. They want a scooter that does everything. It's, you know, portable, lightweight, you can fit it in your car, but it also is the most stable thing and it won't tipple over. So yeah, that's what it looked like. They were, maybe go to the next slide. Yeah, they were very aware that, or I had to, I guess, educate them that it may not be possible to get everything that they wanted out of this, because obviously with a portable scooter, you do not have the same amount of stability as perhaps a larger scooter that isn't portable. So yeah, we had to be very clear that this scooter that they've bought or that they're using was designed for indoors and limited use outdoors. It's designed for use on firm, even surfaces such as concrete, asphalt, and indoor flooring. Just other considerations, they were limited with the space in their home, although they weren't using it in their home, the width of their front gate, so from where they were storing it to taking it out to their car or out in the community was narrow. The client's wife, I guess the main benefit of this scooter was that they can put it in and out of their car and lift it into the boot, and they wanted to be able to retain that function of the scooter. So yeah, wife still needed to be able to lift it in and out of the car. And then I guess the other consideration that I had to make is how this client actually operates the scooter, and are they you know, able to make decisions in terms of, oh, maybe that gutter I shouldn't go down with this scooter, etc., etc. But client was, there was no issues with his cognition, so he was able to make those decisions and make pretty safe decisions. But yeah, just that note there that I sort of touched on, that we did have to provide clear safety guidelines alongside this project. The modification still aims to do what they wanted and to increase the sideways stability, but it's not going to be a magic solution. But they were really super happy with what Dick came up with, and it does enable them to use it in a few more areas than what they previously were able to use it in. So probably best for Hassan to take over the technical aspect here.
Thanks, thanks, Whitney. As you can see from the slide, it's a very clever thinking, simple solution. One of the best thing I like about this project is you are not doing anything to the actual structure of the scooter, which will then void the warranty. All the safety concerns will raise, and you know, might not be safe for the client while riding onto the road. So there's no nut, no bolts, no spanners, no frame alterations, and the way it's these stabilizers are made is like it's just a sort of an add-on accessory and looks cool as well. So it's really easy. It slides you can easily take it off and put it on. So big thanks to Richard and Whitney on doing an amazing job. Thanks, everyone. Anyone's got any question? Okay.
Just a quick comment from Evan again. Everyone probably knows, and if they don't know, aesthetic is very important to me in the solution that we come up with our clients. So it actually looks like part of the product. So and just a quick comment to say, I think it's an excellent finish, and even to the color choice in finishing the item. Great work.
Yeah, and should actually say that the wheels that we used were, we sourced them from Fullshore, who we have a bit of a relationship with. And in terms of getting it on and off quickly, the client has let me know that they can now put it on and off, put it on in 10 seconds.
That's a very good comment. Yeah.
Can I just make a comment? That's basically, that's what design is all about. It's a really excellent design, in my opinion. Simple, no elaboration, just what's needed to be functional. I think it's you really have to be congratulated for from a design point of view. I really like it.
Thanks, Fred. Thank you very much. So I think that was our last presenter. I just wanna request all groups who are in Northmead and in Abbotsford for a group photo, and Marika would take a screenshot if everyone can smile on Zoom.
Yeah, look.
No.
Marika, let me know once you capture. It's done. Yeah. Thanks, Marika. Just a couple of last 2 minutes for Evan for the Lucky Tour prize.
All right. Can everyone see this? This is not a lucky door. This is a lucky helmet. And there are only two conditions to be in this draw. One, sorry guys, you can't be a staff member. And two, you have to be live today. So if we do someone's name out that's not here, I'm sorry, we'll have to do a redraw. I would get one of the volunteers here to draw, but they might pull out their own name here, so that might not go down very well. So I'm going to ask Jake, who's our lead bike mechanic, to do the draw the first prize, which is a $50 Bunnings voucher.
Sorry, everyone, I left my cocktail dress at the dry cleaners. Winner is Alan Stone.
There he is.
Hey.
All right, and our next prize, we have one more prize. I don't know if it's worth much these days, but it's a $50 fuel voucher.
Get you to Bunnings and back.
Pretty much. Won't get back.
Kenny Clark.
Is Kenny Clark live today?
Kenny, are you there?
I don't think so, but yeah, I don't think so. He's in the office or online, but yeah.
Here we go again.
Yeah.
Well, that was two. I can't do that.
Okay.
Sorry. Stop that. Winner is Alan Grimes.
Alan, there he is. $50 fuel voucher coming to you.
Okay, Victoria, it's worth more.
Alan being the.
That might get you a little bit further in Melbourne. I'm not sure.
Did you
compared
have
to
to be
Sydney.
Alan to win today?
Yeah, both Alan.
Yeah, thank you to both Alans.
Thank you, Evan. And again, congratulations to everyone for another exciting series. I think apologies for 15 minutes late from the schedule, and because it was so exciting, everyone was so into it, asking questions. And if anyone's got any questions later on, feel free to shoot me an email, and I'm more than happy to assist. And thanks again.